All right, quick review here, so you can do the worksheet today, since I'm obviously not here. So if you remember from yesterday, ion, there's two types, but an ion is when an atom has a charge. So I would suggest writing down these examples, so take your notes out, write these things down, and then use them to do the worksheet that you're going to get in a little bit. So atom that has a charge is an ion. And there's two ways to become a charge. You can lose E minus is electrons, so lose electrons, or gain electrons. If you lose an electron, right, if you lose something negative, electron is negative, right, an electron is 0 minus 1e, 0 minus 1e, that's the electron. If you lose an electron, you become more positive. So this is a cation, which is a positive ion, positive charge. That's called a positive ion. Something, or an atom I should say, not something, an atom gains a negative, right? If you gain a lot of negative charges, you'll become an anion, which is a negative charge. So losing electrons become positive, gaining electrons become negative. And yesterday I briefly talked about radius. So radius size is kind of how big the atom is. So like a ping pong ball would be smaller than a smaller radius than a basketball, for example. So these atoms on the periodic table all have a certain radius, certain size. As you move down the groups, the radius gets bigger. Well, cations, because they lost electrons, that means they have less shells, so that means they shrink. So cations are actually small, anions get bigger because they're gaining electrons and getting larger. We're going to talk more about that tomorrow, so Wednesday. But I just wanted to kind of review that with you a little bit because I didn't talk about it yesterday. So that's kind of the gist of it as far as cation and anion. Now let's apply that to some practice problems that you can use on the worksheet. So let's take potassium and we'll take fluorine as an example. So if we have potassium, you look on the chart, it's 39 over 19. Mass number, atomic number. Protons, neutrons, electrons. Potassium has 19 protons. Also, it has 19 electrons. Remember, electrons are negative, protons are positive. These two numbers cancel out, so atoms are neutral. 39 minus 19, that gives us 20 neutrons. That's how we get the neutrons. Again, review from yesterday. If we look inside the box on the periodic table, so I'm going to erase this. Well, no, I'll leave that. But if you look inside the box, so, you know, potassium's inside the box, you have numbers. Well, in the top right corner, there's a charge. And all of group 1, potassium's in group 1, they all have a +1 charge in the top right corner of the box on the periodic table. So potassium forms a +1 cation, right? Cation is positive. These two numbers do not change. So 39, 19 do not change. Protons, neutrons, electrons. These two numbers do not change. 19 protons, 39 minus 19, 20 neutrons. That positive means it lost one negative electron. That's why it's positive. It lost a negative, now it's positive. Lose a negative, become positive. So instead of having 19 electrons, like the neutral atom, this has 18 electrons. It lost one electron. It usually has 19 as an atom, but the ion lost one electron, so now it only has 18. And in turn, this radius would actually shrink. So a potassium atom, let's say is this big, potassium ion would maybe be like this big. So it lost an electron, so it gets a little bit smaller. All right, so this is going to help you on the worksheet figuring out protons, neutrons, electrons. Remember, if it's positive, it lost electrons. It lost electrons. The atomic number tells you how many it has when it's neutral, but if it has a +1 or +2, that means it's losing 1 or 2 electrons. Okay, let's try a negative, an anion. So if we look at fluorine, F is 19 over 9. Protons, neutrons, electrons. 9 protons, also 9 electrons, right? This is an atom, so these two will always be the same. Negative, positive, they'll cancel out to 0 charge. 19 minus 9, 10 neutrons. But if you look on the periodic table, top right corner, F is minus 1. F is minus 1. 19 over 9 never changes, that's still the same. But this is an ion, an anion. It gained 1 electron. It gained a negative, so it became negative. So protons, neutrons, electrons, 9 protons, 19 minus 9, 10 neutrons. This number, though, instead of being 9, it's 10. Because it gained 1 negative charge. If electrons are negative, you can remember electrons are negative. Losing them means you'll become positive. Gaining electrons becomes negative. So if it had 9 when it's neutral, but it gains 1 negative charge, that means it gained 1 electron. So hopefully you'll start to see your protons and neutrons don't change. Remember, they are inside that nucleus, and once they're in there, they're not getting out. Okay, nothing's going in, nothing's coming out. They're kind of stuck in the nucleus. So the nucleus stays the same. It's the electrons on those shells outside the nucleus that can change. So negative means gaining 1 electron. So hopefully these two examples with the fluorine and the potassium will help you do the worksheet. Last thing real quick, again with that radius, how big the atom is. If fluorine is this big, if it gains 1 electron, it would get slightly larger. Okay, so that's something we're going to talk more about, like I said, tomorrow or Wednesday. Gaining electrons, things get bigger. Losing electrons, they get smaller. Okay, so hopefully that helps, and obviously I will go over this tomorrow, but the worksheet you're going to be working on right now is due tomorrow for homework. So you have, a good amount of time now to finish it, so make sure you get that done. All right, I'll see you guys tomorrow.